how do you always start? What are you always supposed to look for first? Greatest common factor. That is your best absolute thing you can do. It makes life so much easier. You deal with smaller numbers. Works out really well. So what do they all contain? They all contain a 4. You can divide each of these by 4. If you try 4, you always want to double and check 8 and see if 8 works. What about 36? What is 8 going to 36 next then? No. So 4 is as high as we can go. Is there anything else that they all contain that you can take out? What else do all of them have? They all have an A in them. Okay? So we can take out an A as well. Okay? And you're actually going to divide each one. That's what you're going to do. So if you have a 4A that you're taking out, what's 16 divided by 4 going to give you? 4. And then if you have A to the third, and you take an A out of there, you get an A squared, which is really nice, right? Okay? Got a plus sign. 48 divided by 4? 12, good. And then that A squared, if you knock down an A from it, is just an A. Beautiful. And 36 divided by 4? 9. Good. And then A divided by A? They go away, right? And you could do a little double check here right now. 4, 12, and 9. Is there any numbers that go into all of those? No. So you know you've taken out the highest number that you could, which is really nice. Okay? So the 4A just kind of hangs out. We just kind of like let that chill. Do you know what the next line is going to look like? Whenever you have like an A squared and A in a number, what does the next line always look like when you factor? Yeah, there's like 2 sets of parentheses, right? Knowing that the next line is going to look like that, even in and of itself, kind of kickstarts you and selects you. Is there a preference to the box method or not the box method? Or pro box method, okay? If we go through the box method and you want to see the other way, just let me know. I'm happy to do both for you guys, okay? I don't care how you solve it. I just learned the box method like 2 years ago, and it's kind of great because it works for every scenario, which is kind of handy. So how do you start off this? We have to go what way? So we're actually going to work with our smaller numbers. That's the whole point of that, right? The smaller numbers are way, way easier, right? So first term goes in the first box, and the last term goes in the last box. I like to keep whether they're positive or negative with them, just because it helps me. I always mess up negative, so I do kind of little things to help myself with it. And then really what you're doing is you're splitting 12 into 2 numbers. Do you remember ma'am? Were you ever taught ma'am? You have to be polite when you factor. Multiply, add, multiply. Let you know which ones you need to do what with. Okay? So if you multiply 4 times 9, what do you get? 36. So you want 2 numbers that multiply to give you a 36. But when you add them up, they give you 12. 6 times what? 6 and 6. If you can get it on the first try, that is like gold. Right? If not, I always draw a little chart because sometimes it takes me a little bit. I gotta like list out a couple different things, and then I usually add them straight over and see if I can figure out what it is. Okay. A couple different things you can do. This is really the biggest thing, is figuring out what these numbers are. Once you do that, it kind of becomes a very standard thing you have to do. So since we're splitting 12A into a 6A and a 6A, don't forget to put the A in this one. Okay. We got, and are they positive, negatives? That's something you got to double check too. They're both going to be positive, right? Because positive times a positive gives you a positive, and they're adding up to give you a positive. Okay. What's the next step for this? Yeah, we're just going to take out things. We're just going to factor out things. So if you just focus on this column, what can you take out of all of these? You can take out 2 from both of them, and you can take out an A for both of them. Beautiful. How about this column over here? 3. And whatever this symbol is, no, we're not going to, we're just done. We're frozen. I think it might have died. I think it doesn't like me either. That's kind of really sad. Whatever symbol is there is the symbol that goes here. every time, which is really nice. That's why I always put them there. It's just like a reminder. Okay? How about this row? 2a again in this case. And this guy will be a plus 3 again. And those are your answers. You can check that you did this correctly also, because what's 2a times 2a? 4a squared. What's 3 times 2a? 6a. Here and here. Here and here. So if you have some kind of big number here, and you figured out this one, but you can't figure out this one, divide it. And it helps you out. It's kind of like a nice little check with this stuff. I like it. Makes me kind of happy. So we got 2a plus 3 from here, and we have 2a plus 3 from here. It happens to be the same thing. Do you know how else you can write that? Just in case you get hit with like a multiple choice or something. How else they could write this expression?
40.
They might write it once with a square. Good. Okay, awesome. Just kind of little things to keep in mind. I do not care if you write it this way or this way. It's whatever you have to do. Okay? Cool? The hardest part of factoring is figuring out when you're done. If you've gotten down to where the a's only have a 1 as their exponent, you're done. Okay? Cool? I don't know. Excellent. Alright. What about this guy? Where do you start? Greatest common factor, definitely. Right? So what's my greatest common factor here? 2. And since that's this number, that's as high as we can go, right? So you're actually dividing each piece by 2. What does that land me with? Good. Good. I'm going to throw a 1 in there. You do not have to. 18. Good. Nice. And now you can deal with this guy in the same manner, right? And we know we're going to have some parentheses going on here. Right? I just set everything up first and then chuck in a couple numbers. Okay? Yes, you're going to have to. Okay. We're doing that now. I think this thing really doesn't like me today, guys. So his first number goes in the first spot, or first term, rather. Last term goes in the last spot, and you know that each of these are going to have an X on the end of them, right? Okay. So yeah, which ones are we multiplying, which ones are we adding? 4 times negative 18. That gives you what? 32. Of course I can say negative. And we got to add up to give you what? Negative 1. If you're multiplying two numbers together and they give you a negative, what do you know about those two numbers? One has to be negative. So you know you're going to have a positive and a negative number. Which one will be the larger number? You can tell. What do they have to add up to give you? Negative 1. So what does that tell you about the number sign? The bigger number is going to have to be negative, right? That's the only way to add two numbers together and get a negative, right? If I do 5 minus 3, that's going to give me a positive number. But if I do 3 minus 5, I'm taking away more than I have, right? So we know the bigger number will be negative. Just to kind of help you narrow numbers down. Because this is really the part that gets people, I feel like. Okay? So, what number is multiplied to give you 72? It's okay if you don't get it on the first try. And if you don't know where to start, so we want numbers that multiply to give us these guys. So we have to multiply them together and add up to give you this. So the little goofy thing to remember is you have to be polite when you factor and say ma'am. That's the goofy thing for you. Okay. If you don't know where to start, you multiplied these two numbers together, didn't you? So you could start with these two numbers, right? Sometimes those are the answers, and then you're like, oh, beautiful. So which one of these would have to be negative? It would have to be the bigger number, so 18. When you add those up, what do you get? Negative 14. So are we too far? What's going on here? Do we need the numbers to be further together or closer together? Closer together, right? So you need a number bigger than 4, but smaller than 18. 8 and 9 will absolutely do it. Which one's going to be negative? Negative 9. Beautiful. So you got a positive 8 and a negative 9. Could I put the 8 up here? And the 9 down here? Yeah, no big deal. Okay. Okay. Alright, what do I have to do next? Yeah, we can definitely, both of these, 4 goes into both of them, and x goes into both of them. Beautiful. How about over here? Thank you for saying the negative, because whatever symbol is here goes there. Alright? What does that leave you with on this side? Just an x, right? Because 1 times 4 gives you that 4. And down here, if you've already used up a 9, what's left over from 18? 9. You divide it, right? Divide it. How many times does 9 go into 18? Twice. Right? 2 and 3. Does that make sense?
Why is it like, how'd you get the left side?
So we factored what common factors could we take out of these two? No numbers, so just 1. But they both have an x. And then 2 goes into 8 and 18. That's the highest number that goes into both of them. Okay. So then what do I put over here? 4x minus 9 is one of them. And then x plus 2 is the other one. I got right there. Cool? And how many have we standardized?
Yeah, the test on this.
Yeah, that's all. Next week. No practice what it is today. I got one more for you. One of those weird special case kind of situations, okay? You good? Alright. What's weird? There's only 2 terms, definitely. We got 2 different letters going on, so that's a little different. Kind of. It means you're going to have a variable in the front and the back. Okay? So you're still going to end up having a factor here, but because it's 2 terms instead of 3, which term are you missing? Are you missing the last one, the middle one, the first one? What are you missing? I'm missing the middle guy here. So it's 0. So we basically want something that multiplies to give us that 121, but when we add it together, it gives you 0. What do you have to do to add things together to get 0? If I had 3, what would I have to add to 3 to get 0? A negative 3, right? So you're going to have the same thing, but one's going to be positive and one's going to be negative. You remember these? Like if I had x squared minus 9, do you remember how to factor these guys? Yeah. X minus 3, x plus 3. You remember what they're called? They have fancy words and stuff super often. You know, really. I like it. Conjugate. Yeah, conjugate. And the whole point of conjugates is to get rid of that middle term. That's what they're for. Okay? But if you always have a positive and a negative, what is this middle guy always going to be? Negative. Always. So if this was x squared plus 9, you just walk away. You're done. You can't do anything to it. It's already got a positive outlook on life. Let it go. Done. So how do these compare to each other? 9 is what kind of number? It's a perfect square, right? So we're square rooting everything. That's kind of what we're doing. So what's the square root of 36? 6. What's the square root of z to the 4th? Z squared. Very nice. You are. What's the square root of 121? What? 11, yeah. I'll let you mumble it a little bit. Alright, and then w to the 4th square rooted? W squared. Now this looks similar, right? But it's got a plus sign. That guy's done. This looks similar and has a negative sign. So what can we do? The problems like this with the fourth power, they love this. They love these on SATs, they love them on math placement tests. Because they want to see, do you stop here or do you recognize that you can go one further? Because this is, again, a conjugate. Okay? Mind you, normally they'll give you numbers that you can take the square root of really nicely, unlike Miss Holly did, because she was so sick when she made this problem, and didn't think about it all the way through. But this guy's going to stay the same because of the plus sign, and this guy you can break up again. So you can actually just write square root of 6. Same deal. What's z squared if you square root it? Just z. So now we're down to that first power like we like to be. You still get a plus and a minus, and then what's the last part going to be? The square root of 11 with a w. Okay? So normally they give you a number like 81, because what's the square root of 81? 9, and then what's the square root of 9? 3. So they'll give you something nice that you can actually take that fourth root of. I apologize. Not bad yet. How you feeling? Yeah? A little bit? Factoring is one of those things that the more practice you get, the easier it is, because you start finding the number combinations faster, and you start recognizing, like, if it looks like this, I'm going to have to do this, and if it looks like this, I'm going to have to do this. Okay? And the biggest thing that seems to throw people off is if you take out a greatest common factor, and you're done. So I want you to see if you can start recognizing. Some of them, all you can do is take out a greatest common factor, and you're done. Okay? So once you get the variable to where it's just to the first power, you're like, you're good to go. That make sense? Cool. I can't completely hear.